Example 2, graphing transformations of exponential growth functions. Here we can put this in a calculator and see what happens, but I want to also describe what each kind of thing is doing, right? So we can put this in a calculator, see what's happening, or we can see good exponent to have is 0. What makes that 0? A -4, right? So -4, so there's actually a move left 4. So that +4 right there is actually going to move it to the left. Left 4. Okay, well, what does this -1/2 do? So the negative flips it over the x-axis. X-axis. And that 1/2 is going to shrink that down. Shrink. You can say vertically is fine. Vertically. Maybe there's 2 y's in there too, probably. I don't know. Okay, and then this +1 at the end is just going to move everything up 1. Move up 1. Okay, so if you graph it in graphing calculator, graph it and then describe what each one of these do like this. But basically our base is 3, so it's really behaving just like 3 raised to the x, which is 0, 1, and then 1, 3, and then so it goes down like this, right, and goes up like that. So this -1/2, that's going to flip it over the x-axis, times it by 1/2. So I normally have this point 0, 1. Well, that's going to be 0, or not necessarily 0, but 0, -1/2. So here's 1, so it'd be right there. Okay, then this +4 is actually going to move this point right here left 4, so it looks like this, but it's still, but because it flipped over the x-axis, it's going to look now like that. So it's kind of going to go that way because it's flipping over the x-axis. Okay, and then this +1 is just going to move it up 1, so it looks something like this. And so in the end, it will look like this, and it's going to approach some value, right? Well, what value is it approaching? It's always that k value. So y equals 1, it's not going to cross, right? So I have this boundary here at y equals 1 that it doesn't cross. So I can also graph it that way. Move this point first, deal with the a that's in front, then you can deal with the h that's in the exponent, and then the k at the end, which is also your asymptote that's going there. Okay. And then a good thing, another way you can do it is, what is this value that makes that 0? So it's always the opposite of h. What h, well, technically it's your h. But what value makes that 0, right? And then always just do 1 more or 1 less, right? So here on this problem, I'm going to probably do 1 less. So I'm going to pick -4. And then I want to pick actually 1 more, so -3. And I want to plug in those points and see what I get, and that would help me graph too. So you could do it that way as well. So you can use graphing calculator to describe how it transforms, or you can move that central point 0, 1, right? Find that what that normal one is, that base, graph that, and then move this central point 0, 1, depending on what your a, h, and k are. Or you can always plug in numbers and graph. Right, best one is what makes the exponent 0, and then what makes the exponent 1, and plug those in and evaluate to graph.